Hello, this is a follow-up video, a screencast, so it's not really a video in that way. And the audio is quite bad because I'm probably recording, or I am recording it on my MacBook. I don't want to add a microphone or something. I want to do it quickly and do it low production, so I won't do any post work on this. I will just record it. So the question I got on YouTube is how do, based on my videos about macro photography, the parts. Again, I know very little about macro photography. I'm just trying to get into it. So I got all the parts that people who know what they are doing tell me I need, and I've been fiddling around with them. But by sharing some of the videos, like I always do, I got some questions about what the magnifications are, what the end results are. So what I did, I took some pictures this morning, very early. So some of them are not that great. So again, it's basically to figure out kind of what we are getting as results and to confirm them by really measuring it. So what I did is I used these three parts. Actually, I also tested another lens. I will get back to that in the end. But I used the FE90 millimeter Sony lens, which is a real macro, so 1.1. Magnification. I will explain what that means later. I use a setup lens, so a magnification glass that you can put on any lens very quickly. It has to snap-on feature. You can snap it on, and it's like 5-second job, and then you can magnify your image. And the third thing I tested is extension tubes, and this so this is a raynox 250. While this is a Kenko extension tubes, and it's a 16 millimeters and a 10 millimeters, so combined is 26 millimeters of extension tube, which you can put between your lens, right? So this is what we ended up with, which are a lot of numbers telling us the results. But how did we get there? Well, we got there by taking pictures. So first let me explain some of the numbers, and then we go through them, and you can see that I confirmed or some of these numbers by really taking pictures and measuring them. So we have a sensor in, I'm now assuming that we are using APS-C sensor. I also put some of the other numbers here. If you go to a full frame sort of sensor, then you get more pixels and stuff. But basically I did the calculations on APS-C sensor, which is 23 millimeters in width. It has 6,000 pixels by 4,000 pixels, giving us 24 megapixels. So if they say that it's a 1.1 macro, that means that basically we should be able to take a picture of something which is 23.5 millimeters in width and cover the whole frame. So that's the first picture I took. So basically what I did, I took two sets of pictures for two different lenses. The first one is the macro lens, and I added all these different parts. So the first picture, which is this one, is taking a picture of, let me close this up. Taking a picture of just the lens. How close can I focus into a centimeter? So you can see that we ended up with 1 centimeter, 2 centimeter, 2.3 centimeters. So here's more clear. So that's the line 1 to 2.3.5. So 23.5 millimeters. I put it in 23.5. Ooh! And almost by luck, it's exactly the same. So indeed, we have a magnification of 1. So that's kind of cool. That means for every millimeter in width, we have 255 pixels that we can spend on it, right? So every millimeter will basically, so this part will be covered by 255 pixels in width and about 170 given the aspect ratio in height, right? Because we are not we are not in square millimeters, we are basically doing it in aspect ratio. So these numbers are a little bit off, but not by much. So what it means that on every square millimeter, we can throw 43,000 pixels. So I think that's already quite interesting, right? But let's now go to the first adaptation that we are doing. So we are adding the raynox magnification glass. So, oops. So the second picture, here we go. So this is the full, just the lens, and now we are zooming in, or we are adding the magnification glass. Like I said, a 10-second sort of job. It's really easy, and it's quite small. And now we see that we are in 1 centimeters, I would say 1.2, 1.25. So what did I put in? 1.25, right? So 1.25, doing the same calculations, we are now seeing that we have a magnification of 1.88. So that now means we have 480 by 320 pixels, so about 15,000 pixels we can throw on each square millimeter. So if you have a subject which is 1 by 1 millimeter, you will be able to throw 15,000 pixels on there, which is, you can see, it only is a magnification of less than 2, but you can see how much more pixels we can already throw on it, right? Because of course it's width versus height. You can sort of see that this is way more, right? Almost 4 times more. So that's kind of cool, right? So now we added, or we not added, but we replaced it and only put in the tubes, so the extension tubes. So that's the next picture. Here we go. So 1.5. I would say close. Also not a bad solution. And we see indeed we put in 1.5. Magnification is a little bit less. So we now have 400 by 266 pixels we can sort of throw on the subject. And you can see that we are already losing more than 30% of the amount of pixels on there, right? So the calculations go quite quickly because of well, the width and height combination, right? So what happens if we combine them? So if we combine them with the last picture, here it is. It's a little bit unsharp because I moved it a tiny bit. Again, it was before 9 o'clock in the morning. Didn't have my coffee yet, maybe one. So you can see, but if we take this, so where it is in focus, and we sort of guess a little bit, you can see that we have, this is the half point, right? So we have 0.5, 0.6, 0.7, 0.8, so about 8 millimeters in our whole picture. So 8 millimeters in reality. We have 6,000 pixels by 4,000 pixels because we are not zoomed in at all, right? We are now in full picture mode on Lightroom. So we have 8 millimeters. So we entered 8 millimeters. We will now have a magnification of almost 3 to 1, meaning that we can throw with this combination. So the tubes in here, the lens on top of this lens, we get 3 to 1 magnification, which gives us 750 by 500 pixels that we can spend on every square millimeter. So that means 375,000 pixels that we can throw on there compared to 43,000, right? So you can see a massive improvement, about 9 times as much pixels that we can throw on the subject by adding these two quite cheap sort of parts, right? So the lens is about $1,000. I think the extension tubes are about 100, and setup lens is about 50. So you can see that that's not bad, right? So we also want to make sure that we do it correctly, the calculations, right? So what I did, I cloned this image, right? So the end image, and I zoomed into this little square. So basically, I took, I think, this one, and in the same aspect ratio, I went into the picture and I cropped it to see if the numbers make sense, right? So if I crop into this image into a 1 by 1 millimeter or 1 millimeter width, which of course gives us a little bit different height. So that's why you will see some miscalculation there, but that's what it is. So 107 pixels in width and 480 pixels in height is the real end result. The amount of pixels that I can spend on any square or any millimeter width of real subject, right? So I put in the numbers here just to check myself if I'm in the same ballpark. And you can see 705 by 470 will give us 33,000 pixels, and well, you can see that this is not too bad, right? there's some miscalculation about the aspect ratio, and the rest is just me not doing it precisely enough. But you can see that the numbers kind of make sense. Now keep in mind, we are using a 6000 by 4000 sort of pixels, right? So if we go to an even higher quality camera, let's say in the 7R, you can see that the width and the height becomes much more, and you can already assume that these numbers will go up by a factor of 2 or a factor of 4 because of the width versus height argument again, right? So kind of cool. So I will put in the numbers later if people want to, because I also have to change this number, of course, this number, and then you will get to see the end result. So just to test myself, or to see what happens if you take not a macro lens but just a regular lens, I would I would not say a bad lens, but because it's a very nice lens, but one that is not really made for this job. So I took the Sigma 30mm 1.4, which the specifications claims has a magnification of 0.15 or 0.14. Actually, I ended up with different numbers, so these are the 5 lesser pictures. So in reality, this is the clean picture from without any tools from the Sigma, and and this one is from the Sony. So you can see the major difference already, right? Indeed, this is the width of the sensor, while this one gives us about 22 centimeters, which is the closest that you are able to focus. So the biggest problem is the focusing of this lens. It has a minimal focus distance, I think it was 30 centimeters, right? So you can see the numbers here. 12 centimeters is the best I could do. Yep, that's true. 12 centimeters gives us a magnification of 0.2 almost. So we can only spend 50 by 32 pixels, and the amount of pixels on there is extremely low, right? Even compared to the macro lens, which kind of makes sense. Now, if I add a raynox, not much happened. So let me show. Oops. So it got better. We are now up to 6 centimeters. So I put in 6.2 because I guess that was, if you look more carefully, and you can now see that the magnification already goes to up to 1.4ish, right? And we can already throw 6 times more pixels on there. But if you compare it to the 19mm, it's still quite bad. But then something surprising happened. I put on the extension tubes. So here we are with the extension tubes. Now we can get way closer, which is good news and bad news. Because we can get way closer, because adding 26 millimeters to a 30mm lens is quite a lot, right? It's almost twice as long. And you can see the result here. The minimal focus distance now went to, let's say, 1 to 2.5 centimeters. So that's almost full macro, right? So what we are seeing indeed here, well, we didn't make it to 23 millimeters, we did make it to 25 millimeters, so it means that we have a magnification of 0.94. And you can see now this number jumps up quite dramatically. We are already almost close to the starting point of the 19 millimeters, right? With just the extension tube. Now what is the main difference here is that with this one, with this one, I'm still about 9 centimeters from the front of the lens away from my subject. So it's quite easy to be able to take a picture. The lens is quite far from the subject, even if you want to have it in full frame, right? So if I don't want to have it in full frame, but I don't just want to have the bee, but also part of the flower, that means you can probably be about 20 centimeters away. Well, with this one, I already had to be about 1 centimeter from my subject. So getting close to 1 centimeter of the ant or the bee or whatever is quite difficult. This will work if you are taking a picture, if you can get the light into the picture if you are taking a picture of something which is not moving, right? So, but you can see a big difference. So on this lens, extension tubes makes way more sense than using the magnification glass, right? Now, if you combine them, something I would say shocking happens, but I guess it's relative, right? You can see that if we combine these two, we do have an improvement, but the improvement is not that much. We are getting into 1 centimeters, 2 centimeters, 2.2 centimeters here. And if I go here and indeed I enter 22 millimeters, you'll see we have a little bit better magnifications than 1:1. So that's not too bad. By just adding these kind of cheap parts, we are now getting a 1:1 macro. With the downside, you have to be extremely close to your subject, right? So the lens is almost touching your subject. But we can see we can throw 50,000 pixels in there, which is about the same quality as the macro lens did over there. Again, I try to check my numbers. So in this picture, I think I took something from this dark area. Again, I focused in on the width of one of the millimeters, and here you see the way too dark result, but you can see 257 by 171 pixels. I enter that, and then you can indeed see that the numbers are again not far off, right? Keep in mind that this is an aspect ratio, so it's not really a millimeter height versus a millimeter width. So this number should be lower. That's why this number is indeed lower, if that makes sense, right? Because we are not taking a full width of a millimeter. So so this of course is not. This is 1 millimeter in width, but I did not take 1 millimeter in height. Now this is a calculation mistake, but I don't think many people will use a square image in reality. So in reality, I think using the aspect ratio numbers makes more sense. But that does mean that these numbers are a bit off. Otherwise, they would have been way closer. But you can see that if you compare these numbers with these numbers, that they are not too bad, right? So that also means the end result is with the 19 millimeters and these two combinations, you can get about 375,000 pixels on your subject for every square millimeter, right? So that means, and let's do that just for fun at the end of this video. So we are going to the best result picture, right? So that's the 90 millimeters with a macro tube, with the extension tubes and the magnification glass. And let's assume that our subject is 4 millimeters in width, which is a realistic sort of expectation. Now let's first measure it out. So let's say, which is about 1, 2, 3, 4. So here we go. See, 4 in width, I crop it, but I move it, let's say, to the sharp area of the picture. Well, it doesn't really matter, of course, but let's put it on here and do done. So there we have our picture, and we now see that we have quite a nice resolution of 2800 by 1900 pixels. So that means that if your subject is 4 millimeters in width, so probably smaller, right? So let's say it's 3 because it's in the middle of your frame. You can still throw about 3000 by 2000 pixels on there, which I think is amazing, right? That's quite a good crop into a picture. So hopefully this helped. If the people are still with me in this part of the video, I'm guessing we are now 20 minutes in. Thank you for staying into this video. Hopefully this will help a little bit. There might be some calculation problems. There might be some other things. If that is the case, please tell me. If it's really bad, I will pull it. But I think in general, this gives you an idea, both in numbers and in pictures, showing you that actually the numbers kind of make sense, what these different tools do, especially for these two lenses, right? I'm guessing that you can do the calculation for all the other lenses. I'm also guessing, given how manual focus or autofocus kind of works in different lenses, that you might get different results. So my guess is testing will probably be the best way to confirm if you are getting the results that you expect. So thank you for watching and see you in the next video.